Hey AP Calc students, welcome back. Time for more FRQs. This time we are looking at AP Calc AB exam from the year 2016, and we're looking at question number 6. Question number 6 is another one of those potpourri kind of questions. You could argue maybe it's a little bit of function build, but it's mainly just a potpourri of calc skills, and if you can put this all together, it kind of demonstrates you know your stuff. But it doesn't fit into a nice, clean, other type of pattern of other problems you've seen. So let's see what we have here. Because it's a question number 6, it's no calculator, and it's a little bit of a puzzle. So there's only 3 parts to it, so let's see what we can figure out. I have the table here blown up a little bit bigger because this table of values we're going to need. And you can see right away they have selected values of function f and its derivative, selected values of function g and its derivative. So let's see what they want to know first. It says the functions f and g have continuous second derivatives. So even though there's no values for them, you can be confident there's continuity there. The table above, or to the right, gives values for the function and their derivatives, selected values of x. And those x values are 1, 2, 3, and 6. So, part A, let k of x equal f of g of x. So, I'm going to write that here. Let k of x equal f of g of x. Then it says write an equation for the line tangent to the graph of k at x is equal to 3. Well, you frequently get asked in calculus to write the equation of the tangent line. And that concept has to do with, depending on your preference for format, you can do y equals mx plus b, or other students like y minus y sub 1 is equal to m times x minus x sub 1. So we have the slope-intercept or point slope. Both are acceptable forms, but the whole point, the reason these are so popular, is it's do you know what the slope represents? And so you're asked continually, what's a derivative? What's the derivative? Derivative is the slope of the tangent. More specifically, the formula for the slope of the tangent. So if we can find this derivative, we'll get m. On the question itself, it's giving us x. So we know how to take derivatives. We can put in the x value to get the slope. Done. They gave us the x value. That's done. And so if we go point slope, we just need a y value. So the first thing we need to do is actually evaluate what is k of 3. And that'll give us the y value, and then we can move on to the derivative. So let's get the y value. So k of 3 is going to be f of g of 3. Now, over here, this is old stuff from like Algebra 2, pre-calc, just function composition, so we have to evaluate the inside first and then do the outside. So g of 3 is going to bring us over to our table. So we go over here, there's 3, there's g, so that is 6. So this is the same as asking you what is f of 6. So 6 brings us over to here, and f is 4. So once again, it's just sort of a little bit of a puzzle here. So that's equal to 4. Or if you prefer, you could say this function has, we're finding this equation of the tangent at 3, 4. That's what they're saying. So whichever one you want to do over here, I'm going to say y is equal to 4. 4 is equal to m, x is equal to 3 plus b. Or this method, you're at y minus 4 is equal to m, once we figure it out, x minus 3. So once we get the slope, we're done over here. Get the slope, you want to find your y-intercept, you keep going here. All right, so we've got that. Well, now it's time to figure out what our slope is. Well, the slope of the tangent is equal to the derivative. So we're going to have to figure out what is k prime of x. Well, that brings us back to this, and now we have function composition, which really is one of the ways you can define taking a derivative by the chain rule. So by the chain rule, we're taking a derivative of the inside first, or the outside first, and then the inside. When you're evaluating function composition, you work from the inside out. But when you're doing the chain rule, you work from the outside in. There are some exceptions, to that rule, but most people do this from the outside in. So just a quick little offshoot here, just for an example. So let's pretend we had y was equal to x cubed plus 5x, and that was raised to the 7th power. Well, what we do when we take the derivative is we take the derivative of the exterior first, and we just say, we have a function raised to the 7th power. We need to deal with that first. So we say it is 7. We don't even mess with the inside. We just say it's 7 times the quantity raised to the 6th power. That's the exterior. Then we go into the interior, and we take the derivative of that piece. And so if you wanted, this function could be divvied up into two functions, and you could say, well, the interior function, g of x, that's just the inside, x cubed plus 5x, and the exterior function is f of x, and that is x to the 7th. You could think of it that way, and if you put this function into here, you could say, oh, well, another way to say this would be f of g of x. And this function, put into here, would raise that function to the 7th power. So that's another way of expressing it. But when we go to take the derivative over here, we take the exterior, 7 times the quantity to the 6th, times the derivative of the inside, which would be 3x squared plus 5. So when we express a function with function composition, we take the derivative of the x of the outside. If we want to take the derivative, we say we would do f prime of g of x times the derivative of the inside, g prime of x. So that's what they're asking you to do here. So I need to take the derivative of this function composition. Well, the derivative is going to be f prime of g of x, so that's the exterior, times the derivative of the inside, which is going to be g prime of x. So it's just the chain rule. That's all this is. Okay, and after you see it once, you're probably good. So now we have to evaluate this at 3. So k prime of 3. So now we have to play the game of reading the chart over here. So k prime, I'll just keep going here. This is the slope of our tangent, which is our derivative. So at 3 is equal to, all right, g of 3, let's go over to the chart. So there's 3. So g of 3 is 6. So this is going to be f prime of 6 times g prime of 3. So 3 at g prime is 2. And then f prime of 6. F prime of 6, so there's 6, f prime is 3. So this is equal to 5 times 2, and this is equal to 10. So it looks like our slope is equal to 10, and now I could take that and put it into my equations over here. So now that I have that, I'm going to erase this work to get it out of the way. And we'll polish this off, and we'll say, all right, so now let's put these into these. If you wanted to go this route, you could say y minus 4 is equal to 10 times x minus 3. Done. On this one, we would get 4 is equal to, since m is 10, this is going to be 30 plus b. Subtract that over, we get negative 26 is equal to b. And so we would get y is equal to 10x minus 26. So either of those would be acceptable. So there's the equation of the tangent. So I'm going to take those solutions and I'm just going to write them over here so we still have room to work. So my conclusions were y is equal to 10x minus 26, or y minus 4 is equal to 10 times x minus 3. Okay, and that's a pretty standard skill in calculus class, right? The equation of a tangent of a function, and they give you the function and they give you an x value. Okay, so we are going to get rid of this. Oops. And you can rewind if you need to see that. So this was m is equal to 10 right here. All right. There you go. Now let's look at part B. I'll scoot over to here for that part. Part B. Let h of x equal g of x over f of x. Find h prime of x. Okay, so h of x is equal to g of x over f of x. And they want you to find h prime of 1. So I'll just write find h prime of 1. Well, they just need to, you need to find the derivative first and then put in 1. So, without saying it, they're asking you to do the quotient rule. Do you know the quotient rule? I mean, that's way back earlier in the year. This should hopefully be on the easier side. So we have the derivative of the top, which would be g prime of x, times the bottom, which is f of x, minus the top, g of x, times the derivative of the bottom, f prime of x, all over the bottom squared. Well, if you know that rule, you're going to be okay. And now we just have to evaluate this at 1, and if we can read the table, we should be fine. So we've got g prime of 1 times f of 1 minus g of 1 times f prime of 1 all over f of 1, and then we're going to square it. Okay, let's see what we can do here. G prime of 1. So it looks like we're in the top row the whole time, so that's easy. So g prime of 1, that's over here, that's 8. Times f of 1, that's back over here, that's negative 6. Minus g of 1, there we are at 2. And then f prime of 1, we're at 3. All over f of 1 squared, so f of 1 is negative 6, so we're going to square that, we'll get 36. Alright, so what do we get here? Looks like we have h prime of 1 is equal to negative 48 minus 6 all over 36. So that's looking like negative 54 over 36. And if you can reduce your fraction, 18 goes into those, negative 3 over 2. So h prime of 1 is equal to negative 3 halves. Quotient rule question. And reading a table. There it is. Okay. Okay, let's see what C has in store for us. C says, evaluate the derivative, or the integral, from 1 to 3 of f double prime of 2x dx. Okay. So, let's see here. With the space provided, I'm going to start up high here. I'm going to say, okay, well, they want us to go from 1 to 3 of f double prime of 2x dx. Well, hopefully at this time of the year you know that the result of integrating is the original function. So if this is f prime, the integral would be f. If it's f double prime, the result would be f prime. So what's inside the integral is the derivative of the result. That's why we sometimes call this the antiderivative. So a lot of students just jump right to the answer thinking, oh, this is just going to be, equal. By the way, what I'm writing is wrong, but this is a common wrong answer. A lot of students will just go, oh, it's just going to be f prime of 2x evaluated from 1 to 3. That's the most common wrong answer, but it's a good wrong answer. You just didn't account for the 2x in here. So you have to do a little u sub on this. So what we need to do is account for the fact that it's 2x, not x. It's going to generate a coefficient we have to use. So what I'm going to do is say, okay, well, I would love to just integrate that first, but I need to do a little u sub. So u is going to equal 2x. So du is going to equal 2 dx, which means 1/2 du is equal to dx. It generates a little 1/2. So look what winds up happening. This will be 1 to 3 of f of u dx in transition. Okay, so I let 2x equal u. Now dx is equal to 1/2 du. So I'm going to have, we'll move the c over here. So this is going to result in a 1/2 out front, 1 to 3, f of u, or sorry, I left off my double prime here, du. And now we've got something we can handle. But you got to be careful because these are x values. My interval is x-based right now. And so what I'm going to do is do this problem two different ways here. So I'm going to continue this problem and integrate, and then we're going to see what happens. I'm actually going to move this over. I just need a little bit of width here. Just going to rewrite that. So I have a 1/2 out front, and I'm integrating from 1 to 3, and it's f double prime of u du. Okay? Now again, these are x values. So you got to be careful here. So as a result of integrating f double prime, it would just become f prime. So I would have 1/2 times f prime of u, but I would be evaluating it from x is equal to 1, x is equal to 3. Okay, so now what I need to do is I need to put u back in, and so I'm going to rewrite this step substituting my 2x back in for u. So now I have 1/2 f prime of, instead of u, I'm going to put the 2x back in, and I'm going to evaluate that from 1 to 3. And since everything's now x-based, I'm not going to put my x equals. And now I can read the table and put in my values. So this is going to equal 1/2 times f prime of 6 minus 1/2 f prime of 2. Now we'll read the table, and I get 1/2 f prime of 6. Let's see. 6 here, I'm going to have a 5. So half of 5 minus half of f prime of 2. So f prime of 2 would be negative 2. So it looks like I'm getting 5 halves, and then over here negative 2. So this is plus 1. So plus 1 would be 2 over 2, and so I'm getting a final answer of 7 halves, which is correct. Now I'm going to polish this off. I'm going to go back to a step up here. I'm just going to finish it slightly different for those of you that like this little trick. And I'm going to go back to, let's see, I think I'm going to go back to this step right here, and I'm going to rewrite that here. So this is just for those of you that like to change your interval. So assuming that we get back to this step and everybody's okay, when it was 1/2 the integral of x is equal to 1 to x is equal to 3 of f double prime of u du. Okay, some people like to just convert the entire integral to a u-based, so we could change this and it makes it a little bit easier for some. And so if you recall, I'll put these values up here. U was equal to 2x. I'm just recopying that here. So what I'm going to do is I'm going to put x into that, and I'm going to rewrite my integral. So instead of, since x is 3, 2 times 3 is 6, that makes this 6. X is 1, makes this 2. And so some people like this style a little bit better. You get the same result, so do the one that makes sense to you. So now it's 1/2 the integral 2 to 6 f double prime of u. You would say, oh, well that's just going to be 1/2 f prime of u, and you're going to evaluate it from 2 to 6. And so when you do that, you get 1/2 f prime of 6 minus 1/2 f prime of 2. You go to the chart, f prime of 6 is again 5, so we get half of 5 minus 1/2 of f prime of 2. F prime of 2 was negative 2. A negative 2 here, so we get 5 over 2 plus 1, or 2 over 2, and you get 7 halves that way as well. So I just wanted to show both integration methods in case some of you guys like to convert your interval values. Either way is fine, but we get the same answer. Okay, so again, this was a potpourri of calc skills, kind of cool. Little function composition, chain rule, derivative, slope of a tangent, vocab, mishmash. This one, quotient rule, and can you read a table? Kind of puzzly. And then the last one, can you integrate? And it was a pretty simple u sub. Did you catch the coefficient? And then can you read a table? So that was 2016 number 6. Thanks for watching. See you next time.